I like to start these talks out by telling a story. And first of all, just let's think about this. Why should I care about this? Why should I care about analytics? And this is where I'm going to tell a story for me, which got me really interested in analytics. Didn't start out that way. I was just kind of a bog standard software developer when I came to ThoughtWorks. And we're going to go into this a little bit. And this individual, this is probably one of the first ThoughtWorkers I met about 4 years ago. His name is Bradford Cross. I didn't get to work with him very long because he was already thinking about going to a startup, unbeknownst to us in our team. And what he was doing was this interesting idea that a lot of us that travel a lot run into, at least in the US. I don't know what it's like in Australia, but in the US, planes often aren't on time. And sometimes airlines will do these crazy things where they say, hey, this flight is about to leave about 20 minutes ago. He'll literally say it's about to leave before you're ready. And so what he did was he developed this predictive model with about, 200 lines of code that would tell you with better certainty than any airline will tell you whether your flight's going to be probably delayed. So it would take whether the inbound aircraft is there, what the aircraft arrival status, all sorts of factors to give you a prediction about airline delay. He then left Flightcaster, this company. He eventually sold it, and then started this company called Prismatic. What Prismatic does is it takes what it knows about you, what kinds of things you follow on Twitter, what kinds of stories you've looked at in the past, and gives you a better news feed than you would get otherwise just by going into Google News or something like that and typing in a topic that you might be interested in. Again, predicting what you might like rather than just trying to have you ask for it. So Flightcaster, he was involved with. He eventually sold Flightcaster for, I don't know exactly how much he sold it for. I'm not sure he discloses that, but I understand it's a reasonably large exit that he got out of that. And then used some of his funds from that to then go and start Prismatic, which Prismatic has, at least somewhat recently, I guess this is end of last year, closed on their latest round, $15 million, I think Series A. The bottom line of this, though, is that both apps, the core of their engines in those apps, were a few thousand lines of code. And likely the economic value out of this is going to be in hundreds of millions of dollars. So what got me interested in this is this idea that we can create hundreds of millions of dollars of economic value from a small amount of code. The code to value ratio is actually rather substantial. So now let's really define what analytics is then. Analytics to me is conversion of observations about the world around us into insight, opportunity, positive social outcomes. Positive social outcome for me is, well, getting to know whether the flight's going to be on time. But I think there's bigger things than that we can think about. Figuring out better ways to distribute ambulances in a city, things like that. Certainly opportunity for certainly Bradford and other people that he's been involved in startups with. And certainly insight. So how do we evolve towards what we might call agile analytics? There's been analytics around for a while, and there's been a lot of concepts in the industry that associate themselves with analytics because some of this stuff really is interesting. But for a long time, we've had data warehouses. I imagine there's a lot of IT executives in the room and other kinds of executives who have probably dealt with a data warehouse in the past. And this is supposed to have a lot of, put it in a data warehouse and they'll be able to get all the answers, which is great, but I'm not sure it's ever had the promise that that was supposed to come forth with this. We then got to business intelligence. Every organization has a business intelligence project or program, and they're very good at doing descriptive things, right? We've moved on to analytics from there, which analytics is this idea, well, the descriptive stuff really is interesting, and we run our business on a lot of it, but wouldn't it be really better to be able to predict things about the future using data that we have in an organization? That's what analytics is. And to me, those things are evolving towards what I happen to think is the most interesting thing is really this idea of agile analytics. So the three things I described on the prior slide are things that tended to have a long feedback cycle. And we've been talking a lot about feedback cycles today, and this word continuous comes up a lot. But what I like about this graph is it really kind of talks about what we had to do prior. We would spend a lot of money investing in a platform, operationalizing that platform, and only once we've spent $2, $3, $4 million would we test that platform and then be able to learn something from it or be able to kind of adjust the model. But it was a large investment to get to that very basic bit of actionable insight from data or from other kinds of things we could observe. At ThoughtWorks, we kind of have a different model of how we think analytics ought to work. What we think about is getting something I like to call the minimum viable model. You know, what is the smallest model, you know, of analytics that we can get to? Test and learn, invest a small amount of money, a small amount of time, even weeks. And then if we get something useful out of it, operationalize it, and then use that as a way to get a feedback mechanism to see if the predictions really work. To me, it seems utterly crazy that we would spend $500,000, $1 million, $2 million before we would get any kind of actual insight or feedback into whether an analytics system works. But yet we see that all the time. It amazes me that happens in this or any other industry. So rather than kind of go into more theory about it, let's talk about some examples. So one of my areas of passion is retail analytics, and we're going to talk about other kinds, but I think there's some really interesting things that we could do with analytics technology. So let's say if you're in retail, really a simple question you're trying to answer. What makes a customer likely to buy things? Well, they want to buy products that improve your life at a place convenient to you, that are easy to find. Ideally, you buy from friendly people. There's a reason you buy stuff at Starbucks, maybe not, you know, the coffee shop with the unfriendly people. I don't know what that is in Australia, but I'm sure there's a couple who are able to anticipate my needs. You know, when you go into a store and the salesperson, say you're buying an outfit or a suit, maybe one better than mine, might anticipate that I need, you know, a different, you know, colored pair of shoes for this. People that can anticipate my needs are people I'm more willing to buy from at a time convenient for me. So, you know, maybe the hours need to shift a little bit so I can more easily buy things. And of course, at a price I'm willing to pay, which most people in retail have this holy grail of this thing called dynamic pricing, which is, you know, it might not necessarily be the lowest price. You know, I might be willing to pay more for a better product. So let's dig into this a little bit. Products that improve my life. Well, what if we could answer some interesting analytics questions? What if we could take things like historical product sales, customer demographics, customer research, social media, take that data that we have and get to things like targeted upsell in a store. So when you walk in, we know what you've bought before, we know what your tendencies are, maybe there's something else we could sell you. All sorts of other different kinds of things that could say maybe we need this kind of product and not that kind of product in stores that might be in this or that location. Make it more likely I'll find something that I'm looking for. So one of the really interesting ways this has been done in the past was Target, which is do we have Target in Australia? Okay. So Target got really good at this. They can actually look at what, based on, you know, a bunch of factors, they could actually predict whether somebody was at 3 months of pregnancy, 6 months of pregnancy, 9 months of pregnancy, so forth, and give you very targeted ads in the mail or through other kinds of mediums to determine what is somebody likely to buy. Can we do really targeted placements for things that are have a lot of context for that customer? There's a story where some, you know, I guess it was a teenage girl, 18, 19 years old. Unfortunately, her parents found out she was pregnant by the fact that coupons were coming in the mail at certain stages of pregnancy. It was really an odd thing, but actually kind of an interesting idea as well. So that's one area of that. At a place convenient for me. So, you know, based on customer buying patterns, purchasing patterns, can we do things like store differentiation? So we have this chain in the United States called Walgreens. They have this very kind of iconic kind of store that you see. Well, what they've discovered is that if we have certain different kinds of Walgreens stores, so you have the regular ones that are in most neighborhoods, but in the neighborhoods that have, maybe they're a little bit more upscale, maybe they have a different kind of clientele, they have a special kind of Walgreens that has wine and sushi and some other things that tend to be bought by certain kinds of customers. And so they do a lot more store differentiation based on analytics of what, where certain kinds of customers are. They can do certain kinds of mobile advertising based on, we've talked a little bit about this, the fragmented future, where, based on, where we tend to see you or where you tend to buy, maybe we give you different kind of advertising when you're walking in the store. Stuff like that. In a store where products are easy to find. Now this is where it starts to get a little bit more interesting. What if we were able to do a heat map in which we figured out what square meters have the highest revenue or margin? Where do people buy things more? Where do people buy things less? And I think a lot of retailers do something like this already, but what if we could get much better data around that? What if we could get things into just offline, online purchasing trends. What do people tend to buy offline and then come into the store to get versus things that somebody buys online? What if, even more interestingly, most stores have audio where they can hear if you're trying to plan to shoplift something or something, or they can actually hear what you say. What if we could actually understand what people are saying about products in the store and use that to get insight into additional products that we have that are provided by friendly people? Now, this is also getting really interesting. And so I was doing a little bit of research into this. And imagine if we could use video to determine, are our employees happy? Okay? Now, if I'm smiling and I'm in a happy mood, you can actually look at a video and see whether I'm in a good mood or whether I'm kind of in a bad mood. You can do that. Now, we could use that to say, well, we should pick on this employee, or pick on them for being mad, or pick on them for not being happy enough. That's not really the point of this, because even if you were to do that, if you have a bad boss or somebody that's not very good at raising employee engagement, all you're going to do is fire that person and hire another person, and the same thing's going to happen. So what if we could use this to determine who are the people that run stores to engage employees more or not? And then adjust our staffing of people that run retail locations on that. Well, you can do that. You can actually look at facial expressions using video analytics and then determine, get some engagement data that way. Who are able to anticipate my needs. And so some other things that we could do video capture of facial expressions when somebody looks at a product. We could do all sorts of interesting things. Everybody wants to do this thing in stores like what Amazon could do. When Amazon looks at your buying pattern, they can say, well, somebody went to this product and then they left that page and didn't buy the product. So Amazon gets an advantage over a store which just has to rely on inventory levels varying over time. They don't get that kind of fine-grained data. What if we could actually get an advantage over an online retailer and say, okay, well, if somebody looks at a product and they don't have the right facial expression, or they kind of have an unapproving facial expression, we could really do some interesting things with that. So some really interesting possibilities there. At a time that's convenient for me, so we could analyze what stores have what kind of traffic over what kind of time periods and adjust hours in different places. We could figure out what kinds of things we should offer offline more than online, things like that. And then, of course, at a price I'm willing to pay. This is where it gets to the holy grail of retail, which is dynamic pricing. What you want to do is offer products at what a customer is willing to pay, not necessarily just whatever the lowest price might be. So you won't necessarily do that. You won't have this thing that detects well, how much money do I have in my wallet? So it comes by and it changes the price right there. I don't think we're going to be doing that. I don't even think that would be a good outcome. But the kinds of things you can do is based on the kinds of demographics of people that come into the store, the kinds of all sorts of other factors. You could say, well, I can offer a slightly upgraded version of an item that might happen to have higher margins. And so there's ways you can do slightly differentiated pricing on different kinds of products to get closer to dynamic pricing than you would otherwise be able to. Okay. So retail, maybe not as exciting as certain things could be, but certainly very interesting to a lot of people. I think one of the more interesting things, though, is some work that we've actually been helping a organization here in Australia with, the Search for Intelligent Life. So this is an organization, I believe, hopefully I don't hack it up, ACRAR. Did I get it right? Yes. Good. So we have in Western Australia, a vast array of telescopes out in the desert. And they are, this is where we get into big data, I guess, a little bit. But we're taking in 9 petabytes a second of data from telescopes, putting them through a pre-processing filter, narrowing that down to 100 gigabytes a second of data, and generating this giant database of core telescope output. So we have all this data from telescopes. We're then taking that telescope data, pulling out radio images from that telescope data, doing this thing called spatial energy calculation to generate a spatial energy distribution. So this is a great deal of processing in the spatial energy calculation, generating this thing that data scientists or that actual rocket scientists can use to do spectral energy distribution in this thing called the Bionic open source grid computing platform, otherwise known as doing lots of math with radio images to determine whether ET is actually out there. Now, I don't know if we've actually found ET yet, and they may just not be telling us, but it is a really interesting use of what I think is analytics. So it's really just another analytics problem. We're taking stuff from a camera, or stuff from a sensor, or stuff from maybe a traditional database, and figuring out whether we can answer an interesting question. Is there life out there in the universe? Okay. This is where it really gets to my kind of wheelhouse, or my passion, is data science is really about science. So how do we know, with a given model, did it work? Okay? We heard about in the last talk about continuous delivery. Continuous delivery is about this idea that we don't really know if things work or not until we actually put it into a user's hand and see, did they actually interact with this software to get the result that they wanted? Are the users actually using this software to generate a business result for us? Okay? Well, we have another name for this. Big data may be a fad, right? Analytics may even turn out to be a fad. I'm reasonably certain the scientific method is not ever going to be considered a fad. In fact, we base our entire civilization to some degree on the fact that we have the scientific method and that we can test things, okay? But a really interesting thing about the scientific method is 5/8 of the scientific method is about testing and validating hypotheses that we have. That tells me something. That tells me if we have any kind of process for doing analytics, or data science as some like to call it, if we spend all our time in those first 3 bubbles and don't do the other 5, how are we doing science? I'm not sure that we are. Okay, so 5/8 is about that. Agile Analytics is simply the application of the scientific method, agile practices, lean principles, and so forth to analytics as we understand it today. Okay, that's really all it is. It's really not as complicated as we might make it out to be. So, data scientists. Who here is trying to hire data scientists right now? A few people. I'm surprised. There's a lot of people trying to hire these people. This is, I think it was I can't remember where I read this, but it's considered the rock star title of 2013. Everybody that's a DBA somewhere, they're calling themselves a data scientist. Everybody that knows anything about statistics, they're calling themselves a data scientist now. This is, at least a good way to go out into the market and apparently triple your salary, some people are saying. It's just a little title change. We have a very distinct idea within ThoughtWorks of what a data scientist is, right? At least to us, a data scientist may not have a PhD. Bradford Cross, who I'd consider the guy that helped start Flightcaster and then went on to do Prismatic, I don't believe he has a PhD in stats or math, but many of them do. Many of them have PhD level expertise in science or math. They've done science. I guess that's the key thing we're getting to, is they've actually used the scientific method in a setting over a period of time. Okay? She has an interest or ability to work with developers and implement these things. So, we're hiring a lot of these people, at least in the States, out of University of Chicago and some places like that. We're not hiring out of the theoretical physics department. We're actually hiring out of the practical, side of the organization. Ideally, interest and ability to work with other people, obviously, but to not just refine these math models, but actually work with developers to test them in real life. Usually expertise in few particular methods that are of interest to taking these to a computational context, which is Monte Carlo simulation, machine learning, other techniques that we would use to do practical analytics work in a real project. So if we're engaged somewhere to figure out a customer frustration index, for example, I want to understand how my customers are mad or not, using how they interact in chat logs or how they interact on Twitter or other things. Some of these techniques might actually come in handy for being able to do that. And then another thing that we might look for is expertise in a particular domain. So there may be a specialist like a retail analytics type person, or a other particular domains, a rocket science analytics type person. Okay. Now there are different kinds of technologies that have been traditionally involved in analytics and that we think are different in agile analytics. The traditional RDBMS, a lot of organizations try to build an analytics platform on kind of the old Oracle, SQL Server, DB2 type systems. We find in agile analytics that you actually have to be very open to alternative ways of storing data to be able to actually do a lot of this kind of work. So it might be SQL, it might be kind of traditional stores, but as often as that, it might be things like graph databases, or it might be other Mongo or other kinds of document databases. We have to be open to a lot of different storage mechanisms because there's when you're dealing with big data, that actually becomes an important part of how fast you can process things. You might be buying some kind of big platform. So SAS, SPSS, one of these kinds of tools, they are the traditional kinds of tools that people would use to do analytics. And they're quite good tools. I have nothing against either of those things. However, if I'm a startup, if I am constrained to a $50,000 budget and not a $5 million budget, I may want to use open source tools to be able to do some of this experimentation and not have to put as many, put as much up at stake before I actually get results. So I might use technologies like R, Python, even some of the traditional functional languages like Clojure, F# to do a lot of this work. As it turns out, a lot of what was done with Flightcaster, at least when I was looking at it was based on Clojure, just a functional language. A lot of the proprietary analytics platforms have their own proprietary hardware, software for processing queries. In Agile Analytics, we use the Hadoop ecosystem, often running on infrastructure as a service or what we might call cloud, or stuff like AWS or something on the OpenStack platform. And then, kind of more importantly, so in proprietary analytics, before we conduct an experiment, we might need purchase orders. We might actually need to buy hardware or even procure hardware from some other kind of department. Whereas in Agile Analytics, we just want to make sure the cloud account has a valid credit card. We want to be able to do this stuff multiple times a week, multiple times a day. We want to be able to run other kinds of experiments. If we have to do a purchase order every time we want to try something, it's going to be very hard to make progress very quickly. So, 5 takeaways from this. And I think these are some really important ways to look at analytics as we come away. Think big, start small. And so I've mentioned some ideas here that sound probably a little bit crazy. Should we do video analytics to understand what how happy our employees are? Doesn't that sound strange? Yeah, it does sound strange. Should we start doing that with that entire vision right away? No. We should start small. We should start with the smallest minimum viable model we can start with, get some feedback on that, and then build up to that big thing over time. And we've been talking about this in the context of software for a long time. It applies to analytics just as much. This is actually a more important thing here. So, to me, if it sounds crazy, that means you're doing it right. A lot of these things sound really weird. Google Glass, hey, I got the reference in, probably sounded really weird to Google when they, what do you mean we're going to build this augmented reality? What's augmented reality? When I first heard about that, it just sounded too Star Wars-y for me to think it was a thing. And now it's a thing. Now it's actually something, we've talked about it how many times? 20, 22 references so far? It's, somebody's counting out there. It's amazing, yet that's where the really interesting things are going to come from. Analytics, it's kind of the Wild West. A lot of people, a lot of these ideas just sound too weird to try. So I think if you're the first one to do it, I think it's actually one of the better ways you can innovate. So my hope is this is not Lance Armstrong, by the way, just for context here. But the thing I want people to focus on when they think about doing this in their organization, anywhere else, whether we help you or not, is I want you to think about the person riding the bike much more than the bike itself. And what this matters, in our context is think about the data scientist before you start thinking about the tools the data scientist needs to use. I would invest much more in the top. The bottom, we have good open source tools. Now, you may need a proprietary tool at some point once you've gotten to this point where you think you need the kind of scale that one of those may provide if the open source ones don't provide it. Frankly, I think the open source ones probably provide as much as just about anybody might need. But before you focus on any of that, focus on getting the data science right. Focus on getting the models right. Focus on getting feedback about whether they work or whether the results of them are things that you can operationalize way before you ever buy tools or anything like that or get too involved in writing purchase orders for $1 million things. Though both are important. I mean, tool choice matters, but the science matters much more. So if I'm going to build the dessert there, I'm likely going to need more than just eggs to build that dessert. There's this concept where everybody talks about big data. And at the beginning of this talk, I mentioned big data is kind of it's a buzzword to me, and it's not one I'm particularly impressed by. because lots of people have big data. Okay, there's not an organization on the planet that doesn't have petabytes of data sitting in, especially if you count things like email and other kinds of data that we collect and other kinds of devices, as well as traditional databases. We have big data. The reality is, let's focus on the recipe that gets us to the dessert. Let's focus on the diversity of data. So if you just have eggs, you can't make that. You also need raspberries and a bunch of other things there. Diversity of data actually often matters more than the bigness of data. The stuff that they were doing with Flightcaster, it was actually the diversity of data, weather data, flight late or not late data, and a whole bunch of other things that enabled them to get that prediction made. Okay, that often results in a much better model than if you're just taking it from one source. In fact, if you just take data from one source and try to drive predictions on that and don't have something to counterbalance it, that can actually lead you to very wrong kinds of predictions over time because you don't have that diversity or other kind of information to cross-check data that you're bringing in. One of the other things we like to think about, let's think about this as science. Okay, there's a lot of people in this business right now that are going to try to sell you a solution. They're going to try to sell you something where you can install data science on the server and solve all your data science problems that way. Again, it's really about the people doing it, not about the database science. It isn't about the particular kind of database that you install. It isn't about the particular kind of tool. It's about the scientist himself. So it's this idea, let's actually understand this as a scientific endeavor that we're involved in an organization. We can create incubators where people can start some of these experiments, work on these models, and then take them out. You don't need to hire 20 people to do this. You can do this with a small group of people working on a particular kind of problem. Another thing that we want to do, just as a piece of advice, is don't build a platform. Okay, there's a lot of people that immediately see this kind of initiative and say, hey, let's build an analytics platform before we start trying to solve some problems. Okay, that's focusing, again, on kind of the IT solution or building something for an end user before we can validate it against the real world. Let's not build a platform first. Let's evolve a platform based on real business use cases, and then over time, we will get a platform that we can use and do different things with. Okay, any questions? So he's asking us, have we seen any real world examples where we've done this on the web or some other kind of use case where we've done this kind of work? So we've got two that I can talk about right now. I've got one where we are helping one of our clients build something called a customer frustration index. I alluded to it a little bit before. But what we're doing is it's an organization that provides cloud infrastructure for customers. And they want to know when a customer calls up, what's the mood of the customer when they call? Okay. So we developed a model that took in data from logs. So if they've been getting, trying to procure servers or trying to provision servers and getting 500 errors back when they try to provision a server, other kinds of errors, that's one factor that would come in. When they have other support tickets and they get involved in chat conversations, usually online chat, we do natural language processing over the chat log to see, are they using lots of kind of short sentences that mean that they're angry, or are they using other kinds of language that may not mean that they're as angry? Are they using it could be just the individual words, or it could be the kind of sentence structure they're using, all sorts of things like that. We'll look at the tickets that are coming in. We'll look at, are they increasing usage over time, or are they somebody that tends to complain a lot, but then usage goes up anyway? And so we take about 6 or 7 different factors and come up with this index score, which gives the customer service rep that's taking the call some idea about, well, what should be my stance toward this customer. So that's one case where we're doing this. We have another case where we're helping the city of Chicago do optimization of where they place medical, how should they staff across the city of Chicago, people in different centers for readiness to do 911. So in the US, we have 911 calls. I don't know if it's the same thing here, but it's, are our emergency responders ready and placed in the right places? So we have done some spatial analysis to figure out, what is the mapping of people to, crimes or other things that happen, and how can we optimize that? So we're using analytics over 911 data to more effectively distribute first responders in Chicago, or at least developing models to do that. That work isn't done yet, so we still have yet to see whether that's going to work, but we're working on that right now.
How do people start small? I mean, not everyone has PhD level math people that get on with others. How do you start small? And just how do people with devs and database people just do something useful?
So ideally, this is the thing. I mean, there's some techniques you can do when you start, maybe with people like that. You can usually find one or two people that might understand elements of machine learning or might understand some elements of Monte Carlo simulation. What you're not going to get without a data scientist in the room is this ability to have, well, I have somebody that understands not just one tool, but understands, well, where do I apply this, or where do I apply a Bayesian network, for example, or one of the other tools. So, but you can get started, okay, and that may be the seed you need to be able to do other things. I'm pretty sure in the startup examples I was talking about before, they didn't have a PhD data scientist. They just had somebody that was really interested in a couple techniques that they intuitively knew might work. But they made sure they still started without buying a whole bunch of really expensive tools. And so that's one way you can get started. And then once you establish that you have a real analytics problem that can be solved, and maybe you need some more advanced techniques, then maybe you bring in one of these rocket scientist types that we often like to talk about. So, cool. All right. Yes, one in the back.
Is it working? Yeah. Hi, just a question about the social media entries. Is it possible to actually just to look at the social media entries and analyze, just to predict what's the trend?
Okay. So the question is it just possible to look at the social media stuff and just try to see the trend? Well, there's some things you could do. I mean, one of the things that we like to think about doing is sentiment analysis. And there's actually good things you can, or algorithms that are out there that you can actually, even products you can buy, I think, that do good sentiment analysis and understand maybe a corpus of text, can understand sentence structure to get a sense of sentiment about a product. So some of that stuff is already out there. And there's actually, because it's a well-developed domain, there's a lot of tools to do that. And so if you're interested in doing that, I would probably suggest actually looking at some of those that have solved that problem at least fairly well, and then determine, do I need that or do I need something custom from that launch